Sometimes we're going to see rational expressions that have a radical involved, and there's a radical in the denominator. We made a standard a long time ago in mathematical circles or in the math community that a problem is not reduced if there's still a radical in the denominator. So what we need to do is something called rationalize the denominator, or basically get rid of the radical downstairs. So what I'm going to do on that first problem, root 5 over root 6, is I'm going to try to come up with a number to multiply it by, a clever version of 1. And the one I'm going to choose will in such a way make the denominator, or the radical in the denominator, disappear. Can you think of one? How about root 6 over root 6? Bottom times bottom, root 6 times root 6, that's just a 6. There's no radical. Top, root 5 times root 6 is root 30. And it does appear that root 30 reduces down. So my final simplification is this. Now this number is the exact same thing as that number. Their value is the same. But one is considered more reduced than the other. And it's this one simply because there's no radical in the denominator. Let's look at one with a cube root. The cube root is 7 divided by the cube root of 25. Well, with cube roots, I need to be a little bit more clever because I'm not thinking about square root world any longer. I'm thinking about cube root world. So I need to figure out what's a number that I can multiply the top and bottom by such that the bottom is a perfect cube. Well, what I'm going to do then is I'm going to multiply by the cube root of 5. I know what you're saying. Hey, Willie. Oops, sorry, let's multiply. You're thinking, Willie. That's not the same number. You have to multiply it by the same number in order for it to go away. Well, that's the case in square root world. But in cube root world, not always the case. Just follow along. What's the cube root of 25 times the cube root of 5? It's a cube root of 125. And the cube root of 125 is simply 5. And the numerator, the cube root of 7 times the cube root of 5, that's a cube root of 35. And I'm done. I can't go any farther. 35 doesn't break down in the cube root world. I can't cancel anything else. There's my final solution. And I was able to rationalize, or what we call rationalize the denominator.